Today I'm going to introduce you our work, which is dedicated to some special aspects of hybrid kinetic hydrodynamic model when describing the shape of the shock waves. Modern aerospace and nanotechnologies are in huge need of modern, modern mathematical and computational techniques in a wide range of Knudsen and Mach numbers. And one of the areas to which our work to which our work belongs is the hybridization or combining the hydrodynamic and kinetic models. So for hydrodynamic model, we use the Navier-Stokes Fourier model and the equations you can see here. And the kinetic model is the model kinetic equation for polyatomic gases. The most important thing is that we can also use this one for monatomic gases after some obvious transformations. So in this case, we used a combination method. You can see it here. Variant A is our case because variant B is used for some active surfaces, for example, gas emitting or gas absorbing surfaces, which is the black line. And in our case, we have the white circles, it's the NSF nodes, and the black circles are the joining nodes, and the crosses are the MKE nodes. So we used two different schemes. One is the stationary method, and the second is the relaxation method. And what's very important, we found some interesting model effect, and it doesn't matter of which method we used. So it was not the computational error. We calculated the shape of the shock wave. You can see here the temperature profiles for shock wave, and for moderate Mach numbers such as 1.55, the hybrid model was quite close, the profile was quite close to the MKE model, and that was working only until Mach number somewhere equal to 2. But then when we went to Mach number equal to 7, even if we used a huge a wide range of the kinetic region, we had the derivative discontinuity. But then you can see that the two models, the hybrid and the MKE model, almost coincided. And we unfortunately don't know why this happened. So if someone has any comments, that would be interesting for us, because this is not the computational effect, this is the modal effect. And again, we still don't know why this happened. So this is the figure of the relative error. In conclusion, I'm trying to be as fast as possible. We know that the combination of hydrodynamic and kinetic models of flow can be quite successful if both models are based on the same physical model. In our case, this was true. With a small flow non-equilibrium, including the joining region, the kinetic subdomain of the combined model differs, albeit insignificantly, from the subdomain of the so-called pure kinetic model. And in the case of cross-linking or of joining of models in the subdomain of high non-equilibrium and the presence as a consequence of discontinuity of the derivatives of hydrodynamic parameters, the kinetic subdomain practically coincided with the pure kinetic solution. And again, we don't know why this happens. In fact, that's all why we use the kinetic, why we tried to combine the kinetic and hydrodynamic models, because as you know, for non-equilibrium flows, the hydrodynamic solutions are very inaccurate, and the kinetic models are accurate. And in this case, we tried to combine a fast in calculations, a fast hydrodynamic model and a slow but accurate kinetic model. Well, thank you for your attention. I'm so sorry for being that nervous. This is my email. I also have some contact cards, so if you have some comments on our problem, you can easily contact us. Thank you.